Yeah, so hi, my name is Christiane, this is Domenic. We both work for eBay Kleinanzeigen in Germany, and today we're here to tell you about our journey towards a personalized home feed for our mobile apps. And yeah, we hope that it's going to be useful for you if you ever should start a similar project or even if you're already in the middle of it. But let's start with the basics. So despite the fact that there are some striking similarities in the logo and the name as well, eBay Kleinanzeigen is not the same thing as eBay. We are a very small but happy part of the global eBay family, but we have like 70, 80 employees, and we all share an office just outside of Berlin on some campus. We are Germany's leading classifieds platform. You can virtually buy or sell anything on our site within a certain reason. And at the moment, we have about 25 million live ads. And if you haven't used our portal yet, you might have seen us in public transport. Fun fact about this, these people are actually our colleagues and not professional models. So we get to go to work with them every day and make fun of them for being famous and trying to get selfies, stuff like that. So if we talk about ads at eBay Kleinanzeigen, we don't think about an ad in the original sense. It's not a banner, it's not advertising anything, but it's something a user is looking for or wants to sell. So you can have longboards, coffee machines, flats, cars, or roaring dinosaurs, pink trousers, or funny looking coffee mugs, everything you can find on our site. So if you open our mobile app a while ago, it would have looked like this. So we have a search bar, we have a horizontally scrollable gallery, and then we have a list of our top level categories that you can start using. If one looks at other apps, for example, we have some of the big players here, Facebook, LinkedIn, Pinterest, you probably recognize them. Things look a bit different. So Facebook was, from the start, would present you with a list of things that were happening in your network. And now they also mix some news articles in and some commercials that could be relevant for you. LinkedIn has been doing a very similar thing for a while now. And also Pinterest is also one of these apps where you get recommendations, or the stuff that you see there is personalized for you. So it's not only the big players, it's also the smaller and smaller apps that would start showing you a stream of stuff that's happening on your site or a stream of recommended inventory. And if that becomes like personalized in the choice of items or the sort order of items, we think of it as a personalized home feed. So that's what we mean when we say that. But more and more apps doing that also create some kind of expectation in the user. So they're interacting with our portals every day. They're giving us lots of information about what they actually need and what they are looking for. So if you have any kind of personalization effort, they would expect you to pick up on that, and rightfully so. But then this. So when you come to our site, you actually need to know what you're looking for. You either start searching for something or you start browsing in the categories. And compared to the apps before, I guess we can agree on the fact that this is not very inspiring. So our mission here is quite clear. We would like to inspire our users. We want to be one of these apps that you open when you want to know what's going on in the world. For example, please don't be too distracted by my amazing drawing skills, like when you're waiting for the bus, when you're in a boring classroom, when you're at the beach, or when you're doing any of these other things that people do when they check their apps for what's going on in the world. So yes, feed at eBay Kleinanzeigen. It's actually not a trivial problem because we have lots of users. Thankfully, we also have lots of user interactions, and we have a small development and a very small operations team. So it's not straightforward to us to start ingesting and processing this sort of data. But we do, at eBayK, we're quite proud to be working for like as close as we can in accordance with agile principles. So what we started was a very lean prototype that was supposed to show us if we should go on with that approach, if it's worth for us to have a personalized feed, and to not roll that out to 100% of our users, but to just get the first insights in what that could do for us. So this is what we started with. This is what it looked like. We still had the search bar. At the top, you had horizontally scrollable categories. The gallery was still there, and here you would get a feed of recommended ads. The first implementation didn't touch our backend at all. We just saved a simple user profile on the clients, on the actual apps. And based on that, we would build search queries that would hit our live search index, and from that we would find the ads that would be relevant for the user. So this was rolled out to like small single-digit percentage of the users, and in that way we were able to already measure engagement metrics, and we were super happy. They were all we were looking for. They gave us all the justification we needed to continue with this sort of project. What we could also see at the same time is that scalability already was an issue. It was a big strain on our live infrastructure, and we were pretty limited as to the complexity of the features or of the personalization that we could add to this thing. So this was a showstopper for us. But we had all the justification we needed to go on and look for a more scalable solution. So we stepped back a little bit and looked at all these apps that I've shown you earlier and tried to find information as to how these people build their actual home feeds. And I showed you Facebook, LinkedIn, Pinterest. There's also Etsy, Twitter, Yahoo. All sorts of apps have feed. And very many of them, surprisingly many of them, are nice enough to publish details about what they were actually doing and some high-level architectural insights. So there's lots of stuff about personalized home feeds out there. And I have a slide of references at the end of the presentation. And especially LinkedIn and Pinterest were really interesting for us because they had a very detailed overview about what they were doing. And I would like to generalize these two platforms and what they did on the next few slides. So their starting point is their inventory. For Pinterest, it's a pin. A pin is, in Pinterest lingo, an idea that has a description, that has a title, that has a link and an image. For LinkedIn, you might have notifications of people doing something in your network, interaction of people in your network, or some sorts of documents, groups posting something like that. Because these platforms are super big as well. There's lots of them created every second. And what both of these platforms do is as soon as one of these items get created, it already gets a score. And the score, it's not a global score, but it's already a personalized score. Each of these items gets a score for each user. That's what they say. They also say, LinkedIn also calls it first pass ranking, that these kind of initial rankers need to be very lightweight, very high performant, and that they need to be fast because it's just so many of them. So they're kind of crude and not very sophisticated yet. But it already allows them to get the inventory in some order and pick just the top K items that could go on to the next step for each user. And then this is supposed to be a magic wand, the feed building component, and only the top K items are passed on to that, and there's more sophisticated scoring going on here. And this thing comes up with a more refined score and sorts the final order, and then these items are presented in a user's home feed. What does the magic look like? It seemed from the articles that that's a pretty straightforward machine learning problem. In machine learning, you try to, in classification, you have a target variable that you're trying to predict. In that case, for both of them, it's the likelihood that the user will interact with an item, so they're looking for engagement. So this was L. This is what they're trying to optimize. The higher the score, the more likely a user will click on an item or will like this item. And that's what they're trying to predict. How can they predict it? They have certain groups of things they can look at. They can look at user characteristics like age or interests. They can look at characteristics of the item that they're trying to score, like popularity, source, whatever. And they could have some metadata like recency, things like that. So how do you predict a target variable based on these features? You use some standard machine learning models. What they say is that they use gradient boosted decision trees and or logistic regression, and they build their models like that. Sounded straightforward for me. So it works in my feed. This is how my Pinterest feed greeted me this morning. DIY and baking, can't go wrong with that. My LinkedIn feed told me that there's a shortage of Java developers in Germany. I did click on that as well. So yeah, works for me. So if you were to start building a feed, what could you do? So during the tests that we did, and during reading and researching what other people did, we think that there's two main ways that you can go. You can build something with a pull approach or with a push approach. And I'm going to tell you how. For the pull approach, someone starts interacting with your site or with our site, eBay Kleinanzeigen. Based on that, you save some sort of user profile. Then when the same user requests their feed, it goes to the magic feed building component. The magic feed building component looks into the user profile, builds some kind of query for your live database or live search index, and gives out the items that would fit this user. So this is basically what we did with our prototype. It's it poses extra strain on your live infrastructure, but it's fairly straightforward. You only need a store for the user profile. For the push approach, it kind of starts in the same way. User interacts with site, you save a user profile, but then the rest of the process is kind of turned around a little bit. So as soon as one item comes in, the feed building component looks at the user profile and then determines which of these items fit one user and which of these items should appear in which feed. So the feeds are pre-calculated for each user. So then when the user comes back to the site, they just pick it up and it gets displayed to them. So this gives you some live performance advantages because the feeds are already there, they're already materialized. It also gives you a bit more flexibility as to how you mix the ads in the feed. And yes, it's also much better for degrading gracefully when your system is under stress, because if this gets overloaded, you just calculate fewer updates and the user's probably never going to know. There's a funny scientific paper from Yahoo. It's not even that old. They're trying to make it an optimization problem. They are looking at a hybrid approach of materialized feeds and feeds that are built live. And they're trying to find out when to do which based on activity of the user. So people who are very active should get pre-materialized feeds, and people who just come once a month, they can just hit the live database. So that's it from me. And I am now handing over to Domenic.
Yeah, so thanks for the background. And now everyone hopefully has a little bit of background how other companies have built the feed and why we chose what we did now. So we started with the lean approach, and now we wanted to scale out this, the pull approach, so the one that she explained. So that's great. So then we got to start with these user profiles. How do we calculate them? How do we store them? How is that going to work? So we said we wanted to build it around user data. So that means searches and browse behavior and items viewed. And here we see we have like hundreds of items viewed per second on our live platform, and we have more than double that in terms of search and browse behavior. So yeah, we need to think about like what kind of hybrid solution would fit for this, but we got to make sure that we don't bring down our core platform, because that was one of the very clear constraints. This should live very much isolated from our core product. And yeah, it's too much data to, on a sort of on-demand basis, sift through. So we need some kind of pre-calculated user profile. So that's fine. Looking at it sort of in a more traditional approach, you would generally look at kind of like a batch job. But if you think about a batch job, then you probably think, okay, I need some kind of Hadoop cluster to ingest all this data, come up with some profile. Then I need to store it somewhere, which means I need some kind of pipeline to get the data from Hadoop, to get it into some service, and I still need to store it somewhere for retrieval. So that already sounds quite complicated. And then an additional problem with batching, well, specifically for us, is that if you would batch it daily, that means you come to our site today, we don't have a profile for you, and you might not come back tomorrow. We have a lot of users that are very infrequent to our site. So then during that session that you're there, we show you a feed that's kind of random, and it's not very interesting to you. And so it would be great if you're on our site, you do some searches, you view some items, and within that session, if we could show you some kind of personalized feed. It doesn't have to be amazing, but at least some kind of personalized. So you see that, hey, we have these other amazing items on our site. That can really make a difference. So thinking of it that way, actually, we're thinking, couldn't we model it as a streaming approach? Streaming has become very popular in the last few years. Also, there've been some old frameworks, but there's some newer frameworks. We have more computing power. People have been adopting microservices, so calculating something in a distributed manner. Yeah, it's become, even for the little guy, or well, we're not that little, but even for the little guy, it's already more accessible to start tackling problems in this way. And that's what we set out to do as well. And then comes the choice of streaming platform, like what are you going to use? And these are only a couple that we looked at. There's a bunch more, but we decided to limit it already based on a little bit intuition and what's popular around. And on the left are a little bit the older players. So Spark from Spark itself. They also have a streaming edition. I tried and tested. Apache Storm has been around for quite a while. It's more of a tested player already. And then Apache Flink is a little bit more new. Has been shown really good performance. A lot of people presenting really interesting use cases, doing really well with it. And then kind of like the newest kid on the block is streaming, the streaming edition on the Kafka Streams library. Well, it shipped actually with the normal Kafka library. And I'll dive into that a little bit later. But yeah, we decided, so the biggest difference, I guess, would be, so Spark Streaming is actually not pure streaming. It's actually micro-batching, and with that, you have the overhead of these new tasks and everything. They're all distributed, but on a bigger problem, you start to notice that. Apache Storm is more real streams, but it misses sort of the higher level API, like sort of functional programming paradigms, if you will, so maps, aggregations, kind of those kind of operations. Apache Flink comes with that. And has shown very good performance, also in comparison with the older generation. But then, ultimately, at the end of the processing pipeline, there will be these profiles. And with Apache Flink, I would still have to get some kind of storage mechanism where at the end of my Apache Flink process, I would write that there so to distribute this data. And then, so I still need some kind of pipeline. And this is where Kafka Streams kind of comes in. It's just a library that you incorporate into your normal Java JVM process inside some microservice. And the result and the intermediate stages of the processing, they're actually written back to Kafka again. So they're, by design, it's already distributed. So you could, the result of your processing, you could pick it up with another consumer and start serving that data. Or, as I'll explain later, you can actually already serve it from within the same JVM process. So you kind of can already tell where I'm getting at. We chose to try out Kafka streaming, even though it was very, very, very new. I mean, the versions, I think we started at 0.10, so they didn't even have a full stable release. That's coming out soonish, I think. Anyway, it's I think the next version that's coming out. So yeah, just to reiterate why we went for Kafka for now, it's only Kafka, and that's I think it's important to mention, because like the fault tolerance, how it's in Apache Flink or Spark Streaming, when your job dies, they do some snapshotting and they keep some memory in state so they can recover. But this fault tolerance, it still is something they built themselves. But Kafka, normal Kafka topics already have a very nice mechanism for that, and that's the replication and committing the offsets. And Kafka Streams, it builds on that. So when you lose a service, it'll go out of the cluster. The instances that are still running, they will keep running. And when it's back, it'll just pick up where it left off, because it committed its offset, so it knows exactly where it's been in the stream processing. You don't lose a whole batch. You just lose a couple. You just lose some time, and it'll just pick up where it left off. So that's very nice. Especially very nice is that it comes in a library, so we can just ship it with our normal microservices. So we run Docker images, and we have Marathon as a orchestrator, and we just deploy Kafka Streams applications just like we do normally into our normal cloud, which means we don't have to provision a new Hadoop, new Hadoop cluster. We don't need a Cassandra cluster for the retrieval. At the moment, for our experimental use case, we just plug in the library and we go. So that was for us a very big reason to try out Kafka Streams. And yeah, ultimately, our architecture looks very simple because of that. So we have you, the user, interacting with our web platform or with our mobile, and then you hit our API, so you hit our web platform, and we emit an event. And this event contains the information of what you search for, in which category, etc., or which item you viewed, and with some additional data around that, and we just push that to a Kafka topic. And from that moment on, our core platform doesn't care anymore. So we have our isolation there already. The core platform just does what it does. It just emitted these events. And we can start ingesting these events. So we just have a simple user profile service running, which is just a JVM application, Java application in this case. And inside that service, we're running a Kafka Streams application. So you kind of wrap your service around that library, and it spins up a consumer, and that'll just start ingesting all these messages from these topics, do some processing, calculate these user profiles, and it writes it back to another Kafka topic. So also all our data is safe. So inside Kafka Streams, there's an embedded state store, which I'll explain a little bit more later. But the important thing to remember is that your data is already safe in this Kafka topic. So this is also nice for our side operations, which now don't have to care about yet another cluster and data retention policies and whatnot, but they can focus all their energy on Kafka. So that was also very nice for us. So now, how does it work with these embedded state stores? So inside the Kafka Streams app, for each task is like a partition if you have normal Kafka consumer. So it's a subset of the data that service is responsible for. It'll hold the computed profiles inside the RocksDB data store. So that's on disk inside the container, partially in memory. And the RocksDB makes sure that retrieval is very fast. But then you wonder, okay, but if I lose my data, am I screwed? You're not, because that's, like I said, it's in Kafka. So you can lose your container, you lose all the data, you spin up a new one, it reads out the topic, and it just has a view of the current state of all the user profiles. And the way this scales is, again, because it's just Kafka, you can just spin up as many of these services as you have partitions for your source topics. So when you start out with one, because it's experimental, there's no usage, you're fine with one of these services, you start developing. And then when you are putting it live, you just press in Marathon or whatever orchestrator you're using. You just spin up a couple more instances, and it balances this automatically, and each service will become responsible for a subset of the total data set. So that's the ingestion part, and then we have our profiles on inside these services. And then, calculating the feed becomes as simple as a user comes in, request goes through our feed service. Feed service first looks up what kind of profile they have. Then, as Christiane already explained, it kind of does something with to create these search requests. And then we have an Elasticsearch cluster where it just gets all the personalized ads for you and returns it to the user. And where I think it's good to add that because of this isolation constraint that we have, this is also a separate Elastic cluster from our core search. So we use Kafka for subsystem sort of communication, and therefore this is already decoupled as well. So if you place a new item, that's also pushed to a Kafka topic. All the changes are pushed to that same Kafka topic, and we can just read it out, and we have our own feed view of all the ads we have. So if we don't need some information, for instance, we can just limit it to the information that we want to show in the feed, and we are completely isolated again from our core platform. So that sounds pretty great. And then I guess a question that could come up is, was it a smooth ride? And here, just one main thing that I want to mention is that we were working with a bleeding edge technology, and we've known that. So during getting this to production, we've had a few bugs on the way, some misunderstandings, and we messed up some things. But that's not to bash on the Kafka guys, because they are doing a great job, and they fixed most of these bugs. But it's just one thing we wanted to mention is that think about that before you get on the ride of a hot new technology. There may be some obstacles along the way. Having said that, though, at the moment we are very, very happy with what we have. Like our product works very well. Like our engagement went up like crazy, and our development is also still very fast. So with this lightweight setup, we can really tell the difference between having to maintain your own cluster and have all this complicated data pipeline, or doing small tweaks to the model and pushing it out because it's just one service. And that's been really nice. And we can do, at the moment, we're doing all sorts of A/B tests, and it took some time learning the new technology, getting our heads around it, but ultimately we are, really getting the speed that we want. And again, so the scaling was a non-issue. The way we wrote it for the experiment is the same code that we used to scale out, because the only thing we changed is increase the number of services that we're running. And I think this is really shows you the power of the Kafka mechanism underneath. I was really impressed. And also because now we have our sort of real-time, near real-time profiles. That cold start problem that I talked about earlier doesn't exist for us, and that's amazing. If you come to our site and you do a couple of searches, I would say within seconds we have a profile for you, which means that if you go to our homepage, instantly we can show you stuff that's definitely more personalized to you than something random. So we're very happy with that. And yeah, I mean, what's up next? Our profiles at the moment are very basic still, and I think this is going to be interesting to see how Kafka streams can hold up when you start doing really more sort of computationally intensive profiling. But for the moment, there's a ton of stuff that we can still try, and we really believe in trying out small, lean, getting it to do those things, and then building on that. And so that's what we'll be doing in the future. But for now, we're very happy with what we have. And yeah, that's it. So we have some resources still, things that we found very interesting, like Christiane just said. So I guess we'll share this. And yeah, you can have a look for yourself and build your own feed. That's it. I guess questions?
So do we do the microphone thing, or do we try like this? Either in the YouTube video, or I don't know if there's something planned for the conference slides. But if not, just approach us, we're here. Right, okay, they're going to be uploaded on the code.talks website.
The amount.
Well, like in gigabytes, or? I have no idea, actually. I would ask Grafana for that. I don't know if you have an idea.
I don't have an idea. I'm also not sure. I heard something about we weren't allowed to say all the numbers about how much we had. Yeah. So, but come to us afterwards, and I can give you an indication of a little bit of how much traffic we have and what we do. Yeah, that's a good question. So, so the question is, so I mentioned some advantages of using Kafka, but I also mentioned that there were some tricky concepts and some bumps along the way, and whether we had, for people that want to try it out now, if we have some tips or like things to watch out for.
I think the first one would be is don't upgrade too early. We got on the 0.11 train a bit too soon and had some issues with that. And something that we learned the hard way is that it kind of works when we just use default configuration, but you should spend your time on getting this right, because for like a month or so, this was running with replication factor 1 and nobody really cared. And this is kind of the stuff that you learn the hard way and you have to iron out later anyway.
Yeah, and I would say on that note of default properties, also, don't change stuff if you don't really know what it does. Like, there are a lot of things you can change in the Kafka library, and there's a lot of settings, and they might have very sort of tricky effects, because especially in the streams application, you're dealing with multiple topics and multiple consumers and producers, and yeah, they all sort of work differently. So the consumer has this poll loop, for instance. So you can start playing with that, but that'll have an effect on sort of the underlying producer. And if you don't really understand what that does, and you sort of think, oh, I'll change this, then you might not have a problem on the smaller scale, but then you start, scaling that out, and it might bite you. So I think I think one of the reasons, though, that we are very happy with the Kafka streams is it wasn't yet another thing. So the fact that it was just Kafka meant that we could apply our efforts learning Kafka and not Kafka and Spark streaming and Cassandra and all these other things that would be involved in this complicated pipeline. That made it, at least for getting up and running, I think that was great.
How was your experience with the community, or were there active mailing lists, or whenever you encountered some problems, could you find some help with the developer community or users?
So yeah, question was if community is helpful, right? There's a mailing list. It was pretty active. I got answers for everything I asked there. Confluent, people behind Kafka by now, also have Slack, so you can just sign up and look at what they're talking or what other people's problems are. And we actually we bought some. They also offer consultancy services, so that's something you can take advantages of as well. Yes, please. We haven't done that yet, the pre-computation part. We think that in the long run it will be a hybrid solution, but right now we're happy with the pull one. But if I were to implement it now, I would say I wouldn't just write IDs, but everything you want to display in the feed, because you don't want to hit your database with every ID you put in there, right?
And that's the feed, but I think you were also talking about the user profile. So the user profiles, we do pre-calculate them. So at the moment they consist of some of the recent data you did, and we're working on some experiments with sort of like your favorite stuff, like what you've looked at. You can sort of keep track on that and then define sort of your favorite color or something. So that's something we're still working on. That's currently not an active product, but yeah, and we keep track of the most recent categories you looked at and some of those mostly recent behavior that we can then use to just fire up a request to our search database.
Any difference for you if it's a mobile user, like your mobile app, or if it's a desktop user?
No. Short answer. We track everything. Yes.
Do you prioritize which user profiles you update at all? Like probably the users that are currently online are high priority, but do you do anything else?
So the question is, do we do any priority on which profile we would update? And I think part of this is sort of the beauty of the streaming. So no, we don't. But whenever you do something, it gets updated sort of near instantly. So because we're very current with, they're at their current state. And whenever you do something, it'll go through the streams application and immediately get updated. So it's irrespective of whether you use our feed product. If you interact with the website, your profile will be updated. If that answers the question, yeah.
Order. You first.
Did you look at your parent company, what they do? Do they do something similar? eBay? Or do they look at you to copy your stuff?
We didn't. What we do is we're in this eBay classifieds groups, which have classifieds platforms like ours in different other countries. So we looked at what these people had done. For example, Gumtree UK or Marktplaats in the Netherlands.
Actually, what's your opinion, or maybe you're even considering to use explicit feedback of customers? So, of course, you're measuring engagement and people are interacting with the feed elements, but what's your opinion on giving the customers the ability to say, why am I seeing this? I don't want to see something like this one.
Yeah, so the question is whether we thought about giving explicit feedback, so allowing users to say, I do want to see this, I don't want to see that. It's a good one. We have been discussing it. We haven't decided yet. One of the things I did forget to mention is that what we do want to start with is start incorporating more the implicit feedback. So at the moment, we have functionalities that you can save an ad, or you can save a search or follow another user that has ads. So we're not using that data yet, and we're also not we don't put a lot of weight on the items that you viewed yet. I mean, we have it in the topic, so we use it, but we don't look at whether you actually looked at the thing we presented to you and then give that a higher weight. So that's actually the first step we want to look at, the implicit feedback. And yeah, the explicit feedback, it's a tricky thing. So at the moment, I think our sort of design decision is to keep it as much as a black box as we can. So that gives us the most freedom, and I think ultimately will provide the user with a better product. But that's time will tell.
Yes, please.
Yeah. So I think everybody heard that, right? Yeah. So I understand how it might sound that these are actually a lot of parts, but actually this is sort of the least parts kind of setup that you can have, and I'll try to defend or explain why. Because first of all, Kafka was already a backbone and architectural decision within our company. So all our services, all the communication, the asynchronous communication anyway, all happen already through Kafka. So that's part one. We are very much dedicated to Kafka. So that's one thing. So for us, that's not a hurdle. And in fact, it's a good thing to get more experience and do more with it. The thing where you say like it's plugins and a lot of caches. So it's actually not a plugin. It's very integral to the Kafka library, especially in the new version. And actually, the Kafka Streams consumer is the kind of like the recommended consumer, even if you don't want to do stream processing. So even if you want to do just simple consuming, this gives you a higher level API, which is easier to code with and easier to understand than sitting on a lower level. So in that sense, it was actually simpler. And then in terms of the cache that you're talking about, again, so when you want to do aggregation operations or you want to do joins with other topics, you need a view of the current state. So all these frameworks have that. So Apache Flink also has it. For instance, they have some kind of in-memory state of what's the current state, because otherwise you cannot do these aggregation operations. So you already have it, and the only difference that Kafka Streams guys did is kind of say, okay, we're exposing it. So besides using it for these map and aggregation operations, we allow you to retrieve this data directly. And all you have to do is sort of create an endpoint on your microservice, but we give you access to the underlying data. So that actually meant that, so this cache, as you refer to, like these embedded state stores, they were necessary, but now they're also can be used as retrieval. But should we need other requirements from our services for returning these profiles, then actually what we could do is create a consumer on the topic that stores these profiles and create a microservice just around the read side of this story. You can do that if the setup grows bigger. We've also discussed that, but for the moment, because we kept it in one service to keep it lean and fast. So, did that answer the question? Somewhat. If not, I'm more than happy to dive into it a little bit more.
Okay. Can see no more questions. So thank you again.
Thank you.